In this video, we want to learn about symmetric matrices. A square matrix A, so it is important the matrix A must be a square. A square matrix A is symmetric if the transpose of the matrix A be equal to the matrix. Let us start with an example. Consider this a square matrix. So only a square matrices can be symmetric. Consider this a square matrix 4, 1, 3, 9. What is the transpose of this matrix? If we transpose this matrix, we know that when we transpose a matrix, the rows becomes columns. The first row is 4, 1, it becomes the first column, and the second row, which is 3, 9, becomes the second column. Is this matrix equal to this matrix? These two elements are the same, but because in the transpose we switch opposite elements when we have a square matrix and we transpose it, the position of these two elements changes. 1 goes instead of 3 and 3 goes instead of 1. And as you can see, 3 is not equal to 1, and of course 3 is not equal to 1. So this is not an example of a symmetric matrix. So A is not symmetric. Now can you guess what type of matrices can be symmetric? Can you find a symmetric matrix? Note that when we transpose a matrix, the elements of diagonal doesn't change. They keep their position. 4 is 4 and 9 is 9. They keep their position. But when we transpose a matrix, the opposite elements change their position. And that's the reason that A transpose here is not equal to A. So to have symmetric matrices, the opposite position with respect to diagonal, these elements here and here must be equal to each other. So if you want to write symmetric matrices, or if a matrix is symmetric, this element and this element must be equal to each other. So it doesn't matter what to put on diagonal of the matrix. You can put any number, say 7 and 5. But if you put 4 here, you have to put 4 also here. Now let's see, is this matrix really symmetric or not? What is the transpose of this matrix? 7, 4, and we have to put the second row and second column. And as you can see, the matrix B is symmetric. Let me show you a 3 by 3 symmetric matrix. -1, 2, 3. What element should be here? Note that because here we have 2 and the opposite of 2 is the element that is located here. So here we have to have also 2. It doesn't matter what to put here. You can put any element. For example, 5. Let's put 6 here. But what elements we have to put here? What value we have to put? Because this element is opposite to 3 with respect to the main diagonal. So this element must be 3. And here is opposite to 6. So this element is 6 also. But we can put any value here. Let's put 8 here. This is an example of a 3 by 3 symmetric matrix. Now let's talk about some properties of symmetric matrices. Note that if we have any matrix and we multiply it by its transpose, so if we multiply any matrix by any side, it doesn't matter what type of matrix it is. If we multiply matrix A by its A transpose, or if we multiply the transpose of a matrix by itself, the result A times A transpose or A transpose times A is a symmetric matrix. Let me show you an example. Consider this 2 by 3 matrix. 1, 2, 3, 0, 1, 5. What is the transpose of this matrix? The transpose of this matrix is 1, 2, 3, 0, 1, 5. if we multiply this matrix by this matrix, A times A transpose, or if we multiply this matrix by the other one, the result is a symmetric matrix. Note that this is not a symmetric matrix because it's not a square. And this is not a symmetric matrix. But when we multiply a matrix by its A transpose, the result is a symmetric matrix. We can prove this mathematically, but here in this video we are not looking to prove anything. We want to learn about symmetric matrices. Let's find A times A transpose. 1, 2, 3, 0, 1, 5 times by 1, 2, 3, 0, 1, 5. This is a 2 by 3 matrix. This is a 3 by 2. The result of multiplying these two matrices is a 2 by 2 matrix. Because the first one has 2 rows, the second one has 2 columns, then the answer is 2 by 2. For finding these elements, we have to multiply rows of the first matrix by the columns of the second matrix. The first element is this times this. So 1 times 1, 2 times 2, 3 times 3. 1 times 1 plus 2 times 2 plus 3 times 3, which is 14. If we multiply first row in second column, this element is 1 times 0 is 0, 2 times 1 is 2, and 3 times 5 is 15. 15 plus 2 is 17. Now if we multiply second row in the first column, we have 0 times 1 plus 1 times 2 plus 5 times 3, which is again 17. As you can see, these two elements are the same as we expected. We know that when we multiply a matrix by its transpose, the answer is a symmetric matrix. But what is this element? We have to multiply this by this. 0 times 0, 1 times 1, and 5 times 5. 25 plus 1 is 26. So this element is 26. If you like, you can multiply now this matrix by that matrix to see if this one is also symmetric or not, which definitely it is symmetric. Another property that we have about symmetric matrices is that if we have a square matrix A, note that here we suppose A is a square matrix. So it is, for example, n by n. This is a square matrix, but it's not necessarily symmetric. This is just a square matrix. If we add this matrix, its transpose, so if we add to a matrix its transpose, the result is a symmetric matrix. Let me show you by an example why this is true. For example, consider a 3 by 3 matrix. 0, 1, 2, 4, 1, 5, 3, 1, 9. This is a 3 by 3 matrix which is not symmetric. But if we add to this matrix its transpose, the result is a symmetric matrix. Let's see why. 0, 1, 2, 4, 1, 5, 3, 1, 9. What is the transpose of this matrix? So this is A, and now I want to write A transpose. The transpose is 0, 1, 2, 4, 1, 5, 3, 1, 9. If we add these two matrices, 0 plus 0 is 0. We add corresponding terms simply. 1 plus 4 is 5, 3 plus 2 is 5, 4 plus 1 is 5, 1 plus 1 is 2, 5 plus 1 is 5. We have a lot of 5. Is it 5? It should be 6. 5 plus 1 here is 6. And here is also 6, and 9 plus 9 is 8. As you can see, this matrix is symmetric because the opposite terms are equal to each other. So this is a symmetric matrix. And one thing that I should mention here is that if A is a symmetric matrix and B is also symmetric matrix, it's not necessary that. So note that A is symmetric, B is symmetric. Maybe you think A times B is also symmetric. Maybe it is symmetric, maybe not. So it's not necessary that when we multiply two symmetric matrices, the result be also symmetric. It's not necessarily true. But so if A is symmetric and B is also symmetric, we don't know if A times B is symmetric or not. But if A is symmetric and B is also symmetric, then A plus B or A minus B is definitely symmetric. So when you add or subtract, the answer is symmetric. But when you multiply, it's not necessarily symmetric. It depends to what type of matrices you multiply by each other. I hope by watching this video you have learned about symmetric matrices. If you like this video, please subscribe in my channel. And thank you for watching.